Let's now try to find BFS. Okay, let's say we have such graph and we have to find BFS. Okay, when you have to find BFS, first thing you have to do is draw such cube where we will basically add here numbers. I will tell you later which kind of numbers. Then BFS, the actual BFS that you have to find, right? Okay, while solving, you have always followed these rules. Okay, first of all, it says NQ starting vertex. In our case, starting vertex is 1, right? That means NQ means we write this one here and we write it here. Then after NQ, we write it, we mark it as visited. Okay. All right. Then second one, it says, so now we're now in 1, right? That means in our case, P now is 1. Okay, it says P equals DQ. DQ means now we have to remove it. Then second one, NQ all adjacent unvisited vertices of P. Well, adjacent vertices means the vertices that are connected to, for example, in our case 1. In our case 2 and 3 are connected to 1, therefore they're adjacent vertices, right? It means unvisited vertices of P. NQ all adjacent. That means in our case 2 and 3 they are not visited yet. That means we have to write both of them, 2 and 3 here and here. All right, we're done with one. Then P equals DQ. Now after 1 there is 2, in our case in Q. That means we have to now DQ it, remove it, and here now P is not 1, P 2, because we're working with 2. Then we have to NQ all adjacent unvisited vertices. In our case, adjacent vertices of 2 are 1 and 7. 1 is already visited, 7 is not visited yet. That means we will choose here, we have to mark 2 as visited. Now we will mark 7 as visited, and we write here 7. Okay, and we write here 7 too. Now we are done with 2. Now we will go to another Q, which is 3, right? We will DQ 3. Now we are working with 3, not 2. Then we have to see, here is 3, right? We DQ'd it, and we have to NQ all adjacent unvisited vertices. In our case, adjacent vertices of 3 are 1, 4, and 5. 1 is already visited, 4 and 5 are not visited yet. That means we mark them as visited, we write them 4 and 5, then we write them here too. Okay, next one in our case is 7, right? We DQ it 7, now we are working with 7, and we have to NQ all adjacent unvisited vertices. Okay, 2 is already visited, 8 is not visited yet. That means we write here 8. Okay, now we are done with 7. We move after 7, there is 4. 4. We DQ it. We are working with 4. Okay. NQ all adjacent unvisited vertices. Where adjacent vertices of 4 are 3 and 6. 3 is already visited, right? Yes. 6 is not visited yet. That means we mark 6 and write here 6. All right, then after 4 there is 5 that's coming. Let's DQ it. We are working with 5. Here you can see okay, here you can see NQ all adjacent unvisited vertices. The vertices, adjacent vertices of 5 are 3 and 8, but here you can see 3 and 8 are already visited. That means we don't basically write anything. Then after 5 there is 8. Here is 8, and we have DQ it, and now we have to NQ all adjacent unvisited vertices. And adjacent vertices of 8 are 7 and 5, but since they are already visited, we cannot write anything. After 8 there is 6. Okay, 6. Here you can see 4 is adjacent vertex of 6, but 4 is already visited. That means here is our BFS. And yeah, we have found our BFS. Now, let me explain you DFS in a relatively easy way. Basically, here we have such graph. Here you can see, and we have to find DFS. And look, before, if you have graph and you start solving it, draw such stack, okay, and DFS. Look, I'll explain to you. Here's the rules that you have to follow while solving the problem. Just just write these rules down, and when you're solving, follow these rules. First of all, push starting vertex. Okay, here our starting vertex, this is 1. Okay, we take 1. Here we write 1, we took 1. Here we mark 1 as visited. Okay, and here to DFS we write this 1. Okay, then second one, while stack not empty, p equals stop, push only one adjacent unvisited vertex. Okay, that means now we have to work with 1. Here 1, it says push only one adjacent unvisited vertex. Adjacent means the vertices that are connected, okay, to, for example, to, in our case, to 1, okay. Here 2 and 3 are connected to 1, okay, and these are adjacent vertices. Okay, now we have to choose unvisited vertex. Here you can see neither 2 nor 3 are visited. That means you can choose any of them, but let's choose 2, okay. And when we choose 2, we have to mark them. That means we have visited it, and we have to write to stack these 2, and we have to write this here to DFS, these 2. Now we have to work with 2. We again push only one adjacent unvisited vertex. Here the adjacent vertex that's connected to 2 is 1 and 7, right? It says unvisited vertex. 1 is already visited because here we have written visited, okay, and here we mark it as visited. That means 7, here you can see, is not visited. That means we will choose 7. Okay, when we choose, we mark it as visited, then we write here 7, then we write here 7. Now we have to work with 7. Again, push only one adjacent unvisited vertex. It has 2 adjacent vertices, 2 and 8. 2 is already visited, 8 is not visited. That means we choose 8, we mark it as visited, we write here 8, and we write here this 8. Again, now we have to work with 8 now. We choose unvisited vertex. Its vertices are 7 and 5, right? But since 7 is visited, 5 is not visited. We choose 5. When we choose, we mark as visited, we write here to the stack, and we write here 5. Then again, 5 has vertices 8 and 3. 8 is visited, 3 is not visited. We choose 3. We write here, and we write here. Now we work with 3. 3 has vertices, 3 vertices, 4, 5, and 1. Here you can see 1 is already visited, 5 is already visited, 4 is not visited. That means we will choose 4. Then we write here 4, and we write here 4. 4 has 2 vertices, 3 and 6. 3 is already visited, 6 is not. Now we choose 6. Okay, and we're done. Now, if no valid vertex, pop a variable of p. That means here you can see now we have to work with 6, right? But here you can see there are no unvisited vertex of 6, right? That means we start popping them one by one. We start deleting them and making the stack basically empty. 6, the vertex is 4, right? It's visited, that means we remove 6. 4, the vertices are 6 and 3, both of them are visited. We delete 4, 3, all vertices are visited. We delete 3, then 5, all vertices are visited, 5, then 8, then 7, then 2 and 1. Yeah, now our stack is empty. It's like this, you know, it's like as it was in the beginning. Yeah, we made it again like this. Yeah, this is how we can basically find DFS.